This is Professor Pelton. This is Algebra 2, Chapter 6, Section 1. This is part 2 of the video. So we're using the compound interest formula here. So your standard exponential function looks like y equals a times b to the x. Then we did a modified version of it on the first page, which was the exponential model, which is the y equals a 1 plus r to the t, where we replaced the b with percentages for percentage type problems. And here we're just modifying it again with an n, which is the number of compounds typically used in financial type problems. I put some common n values in here if you don't know how many weeks or days in a year for some reason at this point, and we'll use those to do the basic equations for these three and compare them. So this being our equation we're going to use here. Anytime you have compounding, which means we're applying the interest more than once, um, partially throughout a year. Okay, so we'll write all three of these out at once. So you invest $8,000 in an account for all three of these problems. All three of these problems are 6 years. They all pay 7%. However, the first one, A, is a year, B is monthly, and C is weekly in the compounds. So this is A equals 8,000 is the principal amount, the original amount on the loan, 1 plus 0.07 divided by 1 compound, and 6 years times 1 compound. The second one is 8,000, 1 plus the 7% over compounded monthly, which is 12. So that's 6 years times 12 compounds, which should be 72 compounds overall. If you think about it, there's 6 years and 12 per year. And then the last one, A equals 8,000, 1 plus 0.07 for the 7%. This says weekly, so that's 52. And then 6 times 52. Okay, or 52 times 6. You can put it either way. It doesn't really matter. So none of these will work out to perfect answers. So put approximate. There always has to be some rounding involved. So the first one works out to $12,005.84. The second one works out to $12,160.84. And the last one works out to $12,172.25. So between them, this one, if I can write, pays the best. So more, the most compounds, obviously. So when plugging these in the calculator, you got to be very important to follow the order of operations. If you just smash keys, you're going to get ridiculous answers, and you can't blame the calculator. You can only blame yourself. So we'll do the middle one as an example. So we need to do parentheses, exponents, then multiply. That is the order of operations. Okay, and there's three things to remember. Don't round, and don't round. Okay, so parentheses, we have 0.07 divided by 12. Okay, because you have to divide, then you add your 1. All right, there's our parentheses done. Our exponent is to the power of 12 times 6. And then finally the multiply times 8,000. So that gives us our 12,160.84, and I had to do some rounding for that problem. All right, pause the video, try these student problems for yourself. Okay, so now we're going to lose money in each one of these cases. We start with 5,000. It's 3 years. You lose 2.5%. What is the final amount? So the amount we're going to make is a principal of 5,000 and one. Uh, ah, the marker's messing up there. Hold on a second here. Get my marker going again here. 5,000. 1 plus negative 0.025, or you can just do 1 minus. Either way will work. It's yearly, so it's 1, and then 3 times 1, or 1 times 3, whatever you want. The next one is 5,000. 1 plus negative 0.025 over compounded quarterly, so that's 4 times a year, and that's 4 times 3 years or 3 times 4. Either one you want to do is fine. And the last one, A equals 5,001 plus negative 0.025. Let me make a better one than that. That kind of messed up when I drew that. All right, so you have compounded daily, so that's 365. So that's 365 times 3 years. Okay, so if we start with $5,000 and we're losing, these should be less. So this one should work out to $4,634.30 approximately. This one works out to $4,637.63. And this one works out to $4,638.71. Okay. All right. That is the end of part 2.